Hey, how's everyone doing? Who do we have in the chat? No one's chatted yet. Mubot is here. But who do we have in the chat? I think we sent out the announcement to the class. Mubot was waking up. We were getting everything going. Had to reset the computer. Jessica's in the chat. So good to see you, Jessica. 100 points in the chat right there. We got the Kahoot going and the computer's working again. Oh my gosh. Everything is excellent. Everything is awesome. Daniel, Gracie, Ainsley, Kevin, Natalie, Christy, William, Meath. Good to see you, Jacob, and everyone. We got everyone here. Woo! Let's do this. Starting Kahoot in a moment right here. Where's the music on the Kahoot? William, Rajvi, good to see you here. Good to see everybody. Music's turned up. It is time for that Kahoot. Let's go over to the main screen. Okay. We have the code for the Kahoot on the screen. Who's ready for some Kahoot? Who is ready for some Kahoot? Let's see if people are going to join in. William, will you win the Kahoot? We have here $30 first place, $20 second place, $10 third place. Who got the Amazon gift cards last time? Or you can ask for an Amazon or a Starbucks. Make sure to email me if you win. Tell me which email address to send it to, and I will send it. If you don't get it, please let me know. So that's a big thing. I want to make sure people get it. Did anyone win last time? Got it and be like, I won, I got it. That might be you this time. There's not that many playing. We got like 25, 30 playing, right? Or maybe 20? We might have 20 here. We'll start in 2 minutes. 2 minutes. I got it. Leela right there. Great work. Awesome work. 15 people. 15 with 3 people winning. You might be you, Joyful Boa. We just got 1 minute and 30 seconds or so to go. 16 people. Feeling lucky, says William. William Lovell in the chat too. Both Williams. We're going to see who's going to win. Joyful Boa, and glad we lost somebody. Someone said I'm not going to win. So, even if you don't win. Oh no, we're losing people. Even though when Reagan, good to see you here. Even if you don't win, you can learn. And that's, would you rather get the Amazon gift card or would you rather get 100 on the exam? We're losing people. Brave Wombat, maybe they restarted their name. I would rather ace the exam. So would Charming Lion, maybe. Reagan, so good to see you. Both. Why not both? 100 points right there. So remember, ask questions while we're doing this. Will be about an hour. And thank you to our TA, or our Student Success Center person, right? Shout outs. There was another review tonight. I saw the announcement at, I think, 7:30. So another review tonight, 7:30, thanks to the Student Success Center and our student worker who's helping out with that. So huge shout outs to them. They're doing a lot of hard work. And we'll be starting here in about 40 seconds. Whew. What is it called? I can't think of the name. They are our... Why can't I think of the name? Alyssa Gordon was our all-star. So shout outs to Alyssa. She just set a very high bar for everyone. Got a student... What is it? What are they called again? I know what they do. They help out. They give advice. They help students learn the material. Supplemental instruction, right? SI leader. There we go. The SI leader starting out here in 5 seconds. Daniel, you got it. It's the SI leader right there. Shout outs to SI, supplemental instruction at UT. Huge help. I want some 3, 2, 1s and I'm ready's in the chat. It's time for Kahoot. So we need some I'm ready's. I'm ready's. You know, that's how we roll right here. SpongeBob in the chat. There's no SpongeBob emojis. We need some I'm ready's. We're going to start here in 3, 2, 1. Let's do this. Here we go. Test 2 review. I'm ready in the chat right now. First question of the day. 2 events that can be easily added together must be what? This is a great review question, and use the formula sheet. If you're looking for a review for test 2, you can go to review 2 and you will see the review for test 2. So 2 events that can be easily added together. Super easy. This would be like the probability you make an A on the test or the probability you make a B. If we can add together 2 events, they must be this, easily. There are complex ways. And there's 2 answers. Ooh. So this is called the what rule. This is if you add together 2 events, it's called the what rule. So write this down if you don't have it. This is called the what rule? It's called the addition rule. And the addition rule would be like, what is great job right there, Meath and Jessica. So the addition rule, let's show it on the screen right here. The addition rule, loading up some Word documents. My 10,000 Word documents are loading up in the background. An important part of the addition rule is the following part of it. If we have a team could win, lose, or tie, and we're on a really good team, so the probability we win is 70%, the probability we tie is 28%, the probability we tie is 2%, what is the probability we win or tie? What is the probability we win or tie? What is the probability we win the game or we tie the game? So think about that. We win or tie. And just think about how that works. Just speaking about it, like, well, we have a 70% probability of winning. We have a 2% probability of tying. Great job right there, Jessica. We would have a 72% probability. Great job, William. 72% probability. And just what are you doing with these probabilities? Just think about why this is called the addition rule. And then let's talk about a concept about them. It's the addition rule because you're just adding them. Now tell me, can you win a game and tie that same game? Yes or no in the chat. Can I go and play a game tonight where in that same game, one game, I win the game and I tie the game? Is that possible? No. Great job there, everybody. No, it is not possible. And that's what we would call what? If you can win a game, but you can't also tie it, winning and tying are what of each other. So if one happens, like you win the game, you can't also tie the game. So those events would be said to be what of each other. Great job in the chat. We're throwing some more points. Great job, Davis. Good to see you here too. Gabriel and who else knew? Michaela. They would be called disjoint. Now, the word independent means if one thing happens, it tells you nothing about the other. More on that with the multiplication rule coming up. But disjoint or mutually exclusive mean the same thing. These are the same phrase, just different words for them. But disjoint means, and I think it might help to see the visual. Visually speaking, it's like this. Your team wins, your team loses, or your team ties. These things cannot what? If they are disjoint, i.e. mutually exclusive, they cannot what? They cannot what? If your team wins, loses, or ties, and they're all disjoint events, all mutually exclusive of each other, they cannot what? So think about what it means, and this is what we have to add together events just by adding them. They can't both happen at the same time. Davis, great answer right there. They both can't happen at the same time. But let's say you got some really cool parents and you're going to the pet store and they say the probability you're getting a dog is 70%. The probability you're getting a cat is 40%. And the probability you're getting a bunny is 99% because you got to get a bunny. So now tell me about just these probabilities right here and what you notice about them. If you add together these probabilities, what? Just look at them like 99%, 40%, 70%. What do you notice about these probabilities? It probably looks something like this, like bunny, and then dog, and then cat. In this instance, more than one could occur at the same time. So there's probably a person who gets a bunny, dog, and a cat. So in this instance, this is not just each individual event on their own. Great job, everyone in the chat right there. So these are not disjoint events just by virtue of mathematically speaking. They could not add up. There's points at which somebody gets a bunny, a dog, and a cat. So that is mathematically possible. So we'll look at these later on with more examples. So disjoint means if one event happens, the other events can't happen. Like, would snow be disjoint of it being 100 degrees today in Texas? Is snowing today a disjoint event of it being 100 degrees? And the way to check this is, it's snowing today. Could it be 100 degrees? Are those disjoint? Disjoint means they can't both happen at the same time. So are they disjoint? Could it snow? Great job right there, Meath. They couldn't snow and be 100 degrees. They are disjoint. Because if it's snowing, it can't be 100 degrees. If it's 100 degrees, it can't be snowing. Does that make sense? So mutually exclusive means if one thing's happening, the other would be excluded from happening. And if two things are mutually exclusive, say it in the chat. If two things are mutually exclusive, they can be easily whatted. If two things are mutually exclusive, they can be easily whatted. If two things are mutually exclusive, like we have one that happens and the other that can't happen at the same time, we can easily add together their probabilities. So good review, good stuff. Who's going to be in the lead? Nice job, Leela, right there. Nice job, Gabriella. Good work, Michaela, in the chat right there. We got Royal Boa and Fearless Snail and Charming Lion and Arctic Lion, all the lions and Fast Gator. Here we go with the next question. Let's do it. Two events that have no influence on the probability of each other are what? I like to talk about my brother making coffee in the morning and I make coffee. So if I said my brother making coffee of me is this, then it would mean my brother would say, it doesn't matter if Brian makes coffee. Darren, when he makes coffee, is probably doing it whatly of Brian. Nice job. What can we do with two events that are independent? Like if you say Darren makes coffee maybe 90% of days in the morning, Brian makes coffee 90% of the days, what is the probability Brian and Darren make coffee on a morning? What is the probability that Brian and Darren make coffee on any given morning? So Brian makes coffee 90% of the time. Darren makes coffee 90% of the time. Great job, Michaela, right there. You are correct. And so what would that be? You are right. It's multiply them again together because I don't really influence my brother making coffee. Now, if it's my wife, then you might say, well, if you make coffee, then you have coffee. If you don't make coffee, Brian, it might be because you don't have coffee. So the probability that Darren and Brian both make coffee, and here the key word there, and the probability that Darren makes coffee and Brian makes coffee on any given morning, Brian has a 90% probability and Darren has a 90% probability. So what's the answer? Solve it. 9 times 9. What is it? It's 81%. Meath, great job right there. Another 100 points in the chat. And excellent work, everybody. 81% probability or 0.81 as a decimal. So continuing on to the next question. Who's in the lead? Fast Gator approaching fast. Oh, wait, I think they all got it. Fast Gator, though, was quicker than everyone else. Of course. How can you beat Fast Gator? Haley, good to see you here. To multiply the probability of A and B, the two events must be what? What is a requirement to multiply two events? If you are going to multiply two events, easily, just like you take A, you take B, like, Brian makes coffee, Darren makes coffee, the two events must be what of each other? Just like the last example, this is a review question now. If you're going to multiply two events, Brian makes coffee, Darren makes coffee, you're just going to find the probability of the two events occurring at the same time, A and B occur. We must have independent. Now, these were the other answers. Dependent, well, it wouldn't be dependent. Dependent means like it's snowing today depends on it raining. So if it doesn't rain, what's the probability of snow? Like if the forecast says the probability of rain or probability precipitation, parcip right there, equals 0, then what's the probability of snow? If the probability of precipitation is 0, then what's the probability of snow? You say, I really wonder if it's going to snow today. And someone says, well, there's no precipitation today. You say, oh, well, darn it. Snow depends. Great job, Davis, right there. Snow depends on precipitation. So because of that, you could say on any given day in Knoxville, and great job, Jessica and Rajiv right there. You could say on any day in Knoxville, there's like a 1% chance it snows, 1% probability. So you could say, well, isn't it 1%? Well, if we say there's no precipitation, then the probability right there would decrease. So depending on the precipitation. Now, if we have independent probabilities, we just did one earlier with Brian makes coffee, Darren makes coffee. What's the probability of Brian and Darren making coffee? It means that, what does it mean that Darren making coffee is independent of Brian making coffee? What does that mean? What does that mean that Brian making coffee or Darren making coffee is independent of the other person? What does that mean? If I say they're independent, which means we can multiply them if we want to find out the probability this occurs and this occurs at the same time. So what does that mean, though, that they're independent? They have no effect. Exactly. Like if I make coffee, that will not influence. Great job right there, William and Meath right there. That does not influence Darren to make coffee. Like I make coffee, Darren's not like, I should really make coffee today because he's over in another state. So Darren makes coffee and I'm like, oh, my brother made coffee. I'm going to go make coffee. The Rock knows. It doesn't matter. It doesn't matter if Darren makes coffee. I'm going to make coffee either which way. I'm going to hit random buttons on my computer is what I'm going to do. Where's the next question? Wait. Oh my God, what did I do? Resume. I don't even know how I did that. I might just got a sneak peek at the next answer. I have no idea what I even did. Next question. Here we go. Let's do it. Question 4. Oh my gosh, I might have skipped a question. The probability of a gross jelly bean is 25%. If you eat 3 jelly beans, what's the probability they're all good? So the first jelly bean you eat is good. You eat a jelly bean. It's a good jelly bean. You eat another jelly bean. It's a good jelly bean. You eat a third jelly bean. It's also a good jelly bean. Now, did you hear the key word between you eat one jelly bean and you eat another jelly bean and you eat another jelly bean? So what's the key word right there? You eat your first jelly bean and you eat your second jelly bean and you eat your third jelly bean. You're just going to take it from a random bag of big jelly beans over here. So what would it be? I think I hit skip on a question. What would it be? The key word right there is and. So and means we multiply together probabilities. So what is the probability the first jelly bean is good? Can anyone in the chat tell me what is the probability just your first jelly bean you eat is good? What is the probability that you eat one jelly bean and you're like, oh, that's a good jelly bean. Like, man, I love some watermelon. Oh, we got some buttered popcorn. I love buttered popcorn. So what is the probability a jelly bean is good? Jessica, you got it. Because that's the complement of gross jelly bean. So what's the probability your first jelly bean is good and your second jelly bean is good? Now remember, jelly beans don't care if a jelly bean was good or bad. So your first is good and your second is good and your third is good. 0.75, your first was good, and multiply by 0.75, your second was good, and your third was good, and your third was good. Did I do it too many times? We didn't. Woo, got lucky right there. Great work. Does everyone understand the solve to this? Your first jelly bean was good, your second jelly bean was good, and your third jelly bean was good. First was good, and second was good, and third was good. The probability of 3 good jelly beans in a row, and most importantly, we're multiplying them together because what? Why were we able to multiply these probabilities? Because jelly beans being good or bad are what of a previous jelly bean. Like when you get another jelly bean, this jelly bean being good or bad is what of the previous. Great job, Jessica, there. They're independent. Meath, excellent work right there. They're independent. And Gabriella, excellent work. So they're independent of each other. That's we can multiply probabilities. Who's in the lead? Awesome. Or I think I skipped to, I don't know. Who knows? I don't know. Fearless Snail knows, Royal Boa knows, Rocky Wildcat, Charming Lion, and Arctic Lion. All the lions on the chat. Next question. Here we go. The probability of getting a multiple choice question correct is 80%. With 5 questions, what is the probability you get at least one wrong? Now, these are some of the toughest questions on the test for people. So you must first think, what would you like to have happen on the test? Who knows what you would like to have happen on a multiple choice test? I'm going to help you solve this here in the 90 seconds if you're stuck. What would you really like to have happen on a multiple choice test? You got 5 questions. You've been studying up. What would you like? 5 questions. No worries, Mia. Code's in the corner. You got 5 questions. You can join in Code's in the corner. Check it out. If you have 5 questions, wouldn't it be great to get all 5 questions correct? Well, that's not the answer to the question, but let's think about it. With 5 questions, the probability of getting the first and the second and the third and the fourth and the fifth correct is this. This is the probability you get every single question correct on the multiple choice test. Now, there's only 2 possibilities, though. You'll either get every question correct or what? Now, be careful. Who can fill in the sentence? You'll either get every question right on the test or what? There's 5 questions. You're either going to get them all correct or what? What's the other possibility? It's interesting. I think people often say, don't worry if you get it wrong. You'll either get them all correct or you won't, which means, great job, Jessica, right there, or you'll get at least one wrong, and that's the complement. So the probability of getting one wrong, at least one wrong, is this right here. That's a tougher question, and this is some of the toughest stuff on the test right here. There's some really good chapter. This is chapter 10. No, 12 is 12. 10 is sampling. Let's look at another example of this and see if you can follow along the solve, because this is a tougher question. Okay. We are at a pet store. We're going to let people choose a dog or not dog. So it's free pet day. You have to show that you're going to take care of the pet. Please take care of your pets. So we wouldn't just give out free pets to people we think couldn't take care of the pet. But these people are going to come in and they're going to adopt a pet and they're going to take care of it. There's a lot of pets that need home. Like a dog is like 10, 11 years old. They're going to give it a good home, take care of it, and give it a lot of awesome love right there. So the probability that they get a dog from us is going to be, let's say, 70%. What is the probability the first person walks in and doesn't get a dog? Just solve this. What is the probability the first person walks in? We've got this list of people who are going to adopt pets and they're going to take care of all these elderly pets that need homes. What is the probability the first person? David said it right there. Perfect answer. And Jessica, the probability they don't get a dog. And what do we call this? Because either you get a dog or you what? The probability of getting a dog is 70%. The probability of not dog. Not dog. My D's look like O's. The probability of not getting a dog is going to be equal to 30%. And we call that the complement. So either someone gets a dog or they do not get a dog. We got a bunch of things over. We got elderly snails. We got elderly ferrets. We got elderly squirrels. You can't release them in the wild. They're squirrels. What are they going to do in the wild? So we got all these different animals, but a lot of dogs. So we're going to invite in 4 people to adopt pets. What is the probability that all 4 of these people get dogs? The first person walks in and says, I'm adopting a dog. And we've got unlimited supply. We're not going to say like we're running low on dogs. So we got a lot. There's a bunch of dogs that need homes. So what's the probability the first person gets a dog and then the next person walks in and we let them in the store one at a time so they don't hear the choices of the other people. We say, hey, welcome to our store. We give you the pet that you want and we give it a good home. So what's probably the first person gets a dog and the second person gets a dog and the third person gets a dog and the fourth person gets a dog? Great job, Meath, right there. You got it. Yep. 0.7 to the 4th power. So probably 7 times 7, probably like 2%. 0.02 or something. I'm trying to do it in my head. 0.07 times, no, 24%. I think it's where the 2 is in my head. So 24-ish%. So tell me, great work, Jessica, right there. Either all 4 people who walk in will get a dog, or what? Either all 4 people will walk in and get a dog, or what? What is the other possibility? Either all 4 of these people are going to be leaving with a dog, or what? Just think about how to express it as like, well, either they'll all get dogs, or what? Or they won't. That is correct. And if they won't, so well, all 4 of them could get something else, right? But either everyone will get a dog, or at least one of them won't get a dog. Like maybe these 2 people don't get a dog. So either everybody's going to get a dog or at least one of them doesn't get a dog. Does that make sense when I say it that way? Like think about your classes. Like we could change this example to you have 4 classes now and be the same mathematics. If you're taking 4 classes this semester and the probability of making an A is 70%, what is the probability you make an A in all 4 of your classes? So you make an A in the first class, an A in the second class, an A in the third class, an A in the fourth class, assuming your grades are independent, which is a tougher assumption about grades. And so then think about the possibilities. And this might be where it's like, oh, because either you will make all A's or one of your grades will be not an A, at least one of your grades. Does that make sense to say it this way? Like you're either going to make all A's or you won't make all A's. Like one of your grades won't be in the A, at least one of your grades. It could be none of them are, or you could make all A's. So what is the probability of not making all A's? If the probability of making all A's is this, then not making all A's would be what? How can we mathematically describe the complement right here of not all A's? So how could we mathematically describe the complement of not all A's? How would that be found? Because the probability of making all A's is 0.7 to the 4th. So what's the probability of not making all A's? Because you either make all A's or you won't make all A's. These are some of the toughest questions. You basically have to solve a bunch of these. So Meath right there, good answer. That would be the probability of making all, actually the way I wrote it. Oh, Meath, I think you're right. 100 points. I should have said at least one. At least one is not an A. Oof. I misspoke, I think. At least one is not an A is everything but all A's. I think I misspoke. That's worth some 500 points. I think you answered the question I didn't intend to ask. So at least one is not an A would be everything but all A's. So 1 minus all A's right there. So this is at least one is not an A. Now, making all not A's is 0.3 to the fourth power. Like you didn't make an A, and you didn't make an A, and you didn't make an A, and you didn't make an A. And there's the exact answer. So this is at least one not A. And then the other equation we just saw a second ago was not all not A's. So this is all not A's. And if you understand this, you really understand these types of questions. 0.3 to the fourth power is all not A's. 0.1 minus 0.7 to the fourth power is at least one not A, is not an A. And then 0.7 to the fourth power is all A's. So good work right there. Tougher questions. Good review. Who's in the lead? Let's find out. Ooh, it's a tight leaderboard. Next question. Here we go. Which of the following is a rule of probability? We've been covering them so far. Which of the following is a rule of probability? The other things you don't need to know. A little bit quicker of a slide right here. Which of the following is a rule of probability? Now, probability has a few rules, like the addition rule. You can add together events that are mutually exclusive or disjoint. Multiplication, you can multiply. What's the Kahoot code? Right here in the corner, Brandon. Good question. We also have that probabilities are contained between 0 and 1. So the lowest probability here, 0, means something can't happen at all. And the highest probability, 1, means it must happen. There's one more rule of probability, and it's the set of all probabilities have to add up to what? If you have here everything and they're put different ways, like they're disjoint events, the set of all possible events must add up to what? So it's probability set 1. Davis, excellent work. Davis, you got that great knowledge right there. It's 1. Great job, Christy and Meath also. So, and Jessica, all set of all probabilities, and William also says have to add up to 1. That just means like if you a bunny, then the probabilities of those have to add up to 1 if they are mutually exclusive. Now, you could break it down into the people who get dog bunnies and all these different things, and then you would have all the things that could occur with their probabilities. Who's in the lead? Who's in the lead? Fearless Snail leading the way. We got Royal Boa and Rocky Wildcat. Let's find out who's going to win, though. Here we go. A researcher selects the first 20 roads next to their house. What did they do? I'll tell you what they did. They did bad sampling. We're in the sampling portion. My number one advice for sampling is to have note cards. Use your note cards for these terms. Hopefully this is a nice and easy one. What kind of sampling did they do? We're going to be covering cluster and stratified coming up later. But systematic, which is not the answer, is when you get every kth observation. So remember that for later. Systematic, good one to memorize every kth observation. But this researcher did some biased sampling by taking the easiest roads to get to and did convenience. That's where the 100 points. Great job. Convenience sampling, convenience bias is when you take the observations closest to you. So you don't want to do this. This is completely biased. Bad way to do stuff. Don't do this. Bad sampling right here. Who is in the lead? Who was quick? Leaderboard shakeup. Smooth Quail right there. Let's see who's going to win with the next question. A researcher selects every 5th road on a listing of roads. Now, hopefully I gave a tip. I'm always trying to help review during these, where we say things like simple random sample is giving every road a number and then selecting those numbers of roads randomly. So you just kind of like put them in a hat. Just be like, let's pull out a random. Wow, great job. Stratified, we're going to be talking about here in a moment. That's when you acknowledge a difference in the population and then sample according to that difference. More on that coming up here in a moment. But if I go to the library and I do a systematic sample at the library, then who would I talk to? I go to the library to do a systematic sample. Who am I going to talk to at the library? How am I going to get my sample? Talk to every what? So I'm like, I'm at the library. I'm going to do a systematic sample. I'm going to take every what at the library. What will I do? I want to systematically sample students. We'll sample people at the library. Roger, that's good. We will do that. Every nth, exactly. The nth is the key part of it. Great job, Meath, right there. Gabrielle, awesome work too. And William, we're going to select, you can do every 5th, every 10th. It's going to be every blank person. The amount you do it can be dependent on kind of how big of a sample you want to take. Pick a certain number and stick with it. Yeah, every 8th person, every 20th person. You can space it out over a longer time interval. That's a really good sampling type question to be like, well, what's the time interval we should space this out across? I don't know. We'll figure it out as the research team. Next question. We got Fearless Snail just leading the way. Oh my gosh, more sampling questions to come. Let's do it. A researcher lists all roads and randomizes them, then selects the first 50 roads. We had this question a long time ago, and people get tricked by it. So when you think of systematic is selecting every kth observation. So systematic's not even on here. When you think of convenience is they do it in such an easy way. Cluster is when we take a whole bunch at once. Stratified is when we acknowledge a difference and sample according to that difference. Simple random sample is when everything gets a number and then we randomly select those numbers. Now, the trick to this one, which sometimes catches people, is, we had some stratified. This wouldn't be stratified because we haven't acknowledged a difference and selected according to that difference. A lot of times people think it's convenience because we select the first 50, but it's still just random roads. It's like if you go to the registrar and you say, give me a random list of students, and then you give every student a number of randomly, and then you select the first 50 random students. Well, it's still random. You just randomize the order. So what are the key steps to simple random sample? Everything gets a number. Then you choose the numbers randomly. We list out everyone, and then we give them numbers, and then select, list of all the roads and randomize the order, then select the first 50 roads. So they've been randomized so that we just get 50 random roads. And that is what a simple random sample is. If we went to UT and said, can we have a list of all students? We'd have to give every student a random what? How would we take a random sample of students? I want to get 100 students. I have a list of all the students. I give every student a random what? What do we do? I want to take a random sample of students. Simple random sample, rather. How would you take a simple random sample? I give every student a number. And then I just, right there, you got it right there. And Jessica, great job. Mubot loving some randomness. So, and Rajiv, great job right there. We would give the students a number and then probably just select numbers 1 through 50. Why numbers 1 through 50? Well, they're random. Obligatory random. Next question. Let's see who's in the lead. Fearless Snail still leading the way, but Fast Gator just jumping back on that leaderboard. Oh my gosh. Here we go with the next question. A researcher selects their sample based on the percent of highway, country, and city roads, acknowledging a difference. They're saying, I'm going to take like 40% country roads, take me home. They're going to take 30% highway roads and 30% city roads to kind of acknowledge differences between the way the roads are in Knoxville. They're looking into potholes and seeing what the problems are with potholes in Knoxville are. So when they do this and they acknowledge a difference and they make sure that they collect according to that difference, what are they doing? This is where I get scared. And we got the pros here today. Great job. I think you probably heard me say it a bunch of times. When you acknowledge a difference, you are stratifying. So if I go to Krispy Kreme and I say, give me a box of donuts, I'm getting a what sample? If I say, give me a box of donuts, I'm going to tell you how those donuts are. Or actually, give me 3 boxes, and I'll sample every donut inside that box. If I go to Krispy Kreme and I say, give me 3 boxes of donuts, I'm doing a what sampling method. So I just say, give me 3 boxes of donuts, and I'll do a census on those boxes of donuts. So just give me a bunch of donuts at once. We're doing cluster. Gracie's got that knowledge right there. We're doing cluster. So cluster, and Meeth's great job right there too. Cluster is when you take a whole bunch at once and you don't acknowledge differences. You just say, give me a bunch. You go buy a 6-pack of Coca-Cola. That 6-pack is a cluster. How could we stratify Coca-Cola? And you want to acknowledge a difference. So we're practicing stratification versus clustering right now. How could we stratify Coca-Cola? Can you acknowledge a difference between Coca-Cola? Like there's this Coca-Cola, there's that Coca-Cola. By flavor, we got like cherry Coke and regular Coke. Great job, William. We're making you a mod, William. Diet and regular Coke. There you go. You're acknowledging differences. And that's what stratifying is. So maybe if we work at the Coca-Cola factory and we want to see if there's a problem on the lines, maybe we have 50-50 Coca-Cola versus Diet Coca-Cola. So we take 50% off the Coca-Cola line and 50% off of the Diet line. Now you might say, isn't that a whole bunch? Well, we're acknowledging a difference. If you take a 6-pack of Coke, that's a cluster sample. If you go to the lines and say we want half of our sample from regular Coke and half from Diet Coke, You're acknowledging a difference. Look for that key characteristic right here in stratified, where you say like, okay, I need this percent from this group and this percent from this group. Why do we stratify? You might say, well, why do we do this? We stratify to make our sample what of the population? Because if I go say, just go give me some Coca-Cola, the person might go to just the regular Coke line because it's nearest to them and take a convenience sample and take the first 100 bottles off the regular Coke line. I say, no, we need to be this of our population. Stratify, give me half and half. Don't pour them together. Just give me 50 Coke bottles and 50 Diet Cokes. We want, by stratifying, to make our sample what of the population? What's a key word in sampling? I think it's more representative. Great job, Jessica, right there. More representative. So that way we actually have the inherent differences and great job, Mia, right there, and William. So we have the inherent differences in what we're looking at. So it's representing the population of interest. So we say, get this amount and this amount within the groups. Next question. Fearless Snail. Ay. Let's see who wins here. A researcher decides to take 5-mile segments of roads and sample each 1-mile segment within, performing a census on that 5-mile segment. Wait, what? Performing a census is a key phrase we should know? When you perform a census on what you collect a group, and you sample everything within? Almost sounds to me like they're buying a box of donuts and then sampling every donut in that box of donuts. That's what it sounds like. It sounds like this is what sampling. So they're taking a whole bunch at once, and then they are sampling every observation. Good work. What is the key thing you should see when you see a cluster sample? What is the key thing you should see? And be careful. I do know of a few tricky test questions, but the one I'm thinking of, which I don't want to say, it does say they take all of that. So if you see a test question, there's little hints right here. If you see a test question that acknowledges a difference, but then takes all of one group, what kind of sampling method was that? If you see a test question that does acknowledge a difference, like we said something like, or right there, Rajvi, we would say something like, UT is interested in collecting data on students. They have freshman, sophomore, junior, and senior classification, and they go and they speak to all the freshmen. So let's take a vote. Let's write this question in the chat, and I think people see the answer. UT wants to understand students. They have freshmen, sophomore, juniors, and seniors. Darn, it's too long of a question. It would be clustering. Even though we acknowledged a difference, we just took all of one group. We didn't actually sample according to that difference. Does that make sense? Like if we go and we just sample freshmen and get all freshmen, like all the freshmen, the performing of a census on one group is a cluster sample. So even if we say, oh, well, let's just go get data from all the freshmen, then we're kind of doing a cluster sample on freshmen, even though we're talking about freshmen, sophomore, junior, senior. Watch out for tricky questions like that. Maybe you'll see one when you're taking the test and be like, that's that one that Brian was talking about. We always have a little bit of teaching to the test moment. Ooh, who's in the lead? Fast Gator, no! You got this, Fast Gator. I'm rooting for you. I just like seeing you jump up on the leaderboard here, so you got this. Sorry, everyone else. I'm rooting for Fast Gator. The researcher takes too many city roads. What kind of bias do they have? Now, the biases we have right here are things like response bias. This is when the question, the researchers, or some type of thing influences someone to respond differently. We have non-response bias. This is when we do not get answers, so it's a non-response. We have convenience bias, which goes with convenience sampling. This is when we basically get the easiest things. And last but not least, we have undercoverage bias, which also means we might get too many of something else. So if you undercover city roads, you overcovered something else. So undercoverage bias means you got too few of something. So any questions on these? Let me pause. Who has questions? I feel like we got everyone is so intently focused and trying to win because there's a fewer amount of people here, and everyone, I feel like there's a lot of focus, which I like. But I want to make sure if there's questions you ask them. Like, does everyone know what non-response bias is? Response bias, convenience bias, undercoverage bias. So cluster also acknowledges the difference when we sample everyone in the group. Cluster really doesn't acknowledge a difference. It could, like, the key characteristics, Meath, good question right there. The key characteristic to clustering is the census of a whole group. So I like to use the example of going to Krispy Kreme and saying, give me 3 boxes of donuts, and then eating every donut in each box. So a box of donuts is just a box of donuts. If we wanted to do a cluster sample of students, it'd probably be a good idea just to talk to tables of students. So like you would just go and talk to 10 random tables. The tables are not meant to be different from each other. Yep, exactly. Great question right there. Is undercoverage bias when there's too much or too little? So that's a great question right here, Leela. That's kind of the trick of this question, is that if you overcover something else, like imagine if you only talk to freshmen, you would what the freshmen. Now, I know it's not this word, but if you only talk to freshmen to understand UT students, you would what the freshmen. If you only talk to freshmen, you would what the freshmen. So we want to understand UT students and we only talk to freshmen, so you would what the freshmen. If you only talk to freshmen, you would overcover the freshmen, right? Which means you would undercover all the other groups. So overcoverage leads to undercoverage. So if you take too many of one thing, you get too few of something else. So this is kind of a trick question right here. It does work. And hopefully, Leila, does that make sense right there? If you overcover one thing, you will get too few of something else. So if you only talk to freshmen, you'll have too many freshmen and you won't cover enough of the other classes. You're welcome. Thank you so much for those questions. 100 points, both of you right there. Keep those questions coming in. Rocky Wildcat, you're doing a great job. And so are you, Fearless Snail, and Roller Boa, and Charming Line, and everyone else. Fast Gator, still rooting for you. Here we go. Next question. The researcher collects roads near their house. The researcher collects roads near their house. So the researcher collects roads their house, near their house. The researcher collects roads near their house. Pretty easy one. Other than the typo, I think we're fine. Typos, they happen. What do you say to someone who likes grammar? There. You don't see that right there, so that's a joke. Convenience bias, I think we got this one down. 100% right there. Excellent work. Convenience bias, don't do this. Don't just take roads right near you. Not a good idea. Not going to work. Next question, let's do it. Leaderboard is tight. The list of roads the researcher has access to sample. Ooh. Yeah, those are tough, right, William? I've done those for like 10 years, and sometimes I'll even get tripped up. Those are the ones I get a little bit afraid of. Now, this is a great question right here, and we try to be as clear as possible on the test, William. On the test, we try to make it like super clear. Please tell me if you have any questions after taking the test, but it's like as clear as we can possibly be. If you have access to sample something, we did this during office hours today, it would be in your what? If you have access to sample, great work. It's in your sample frame. So the sample frames are things you can sample. If I go to Hodges Library to understand UT students, and I talk to 100 students, who was in my sample frame? I go to Hodges Library to understand UT students, I talk to 100 students, who was in my sample frame? So who would be in my sample frame? Brian goes to Hodges Library, talks to 100 students. That's a good answer right there. Kind of. Mubot getting excited in the chat. Kind of. There you go. Meath got it right there. Students who are in the library. The 100 students is the sample. And then Mia, I think Mia did a better, all his answers are great right there. Mubot just so happy to hear UT in the chat. The people I could possibly speak to would be UT students in the library. I think that's the A+ answer. Great job. We're throwing 500 points for all those answers. So the 100 students is the sample. UT students is the population because I want to understand UT students. And does it make sense? I can only, if I'm in the library, finish my sentence, I can only speak to students who are what? This is why it's a sample frame. The sample frame are the ones you have access to. If I'm in the library talking to students, I could only talk to students. There you go, Jessica Caesar right there, in the library. So I could theoretically, I think this is the hard part for people, is the sample frame is theoretical. Could I speak to any student in the library? Maybe could I walk up and they might be like, they might say this. And what if they're saying, hey, I gotta go. Why are you talking to me, random person? Sam Brown seems to say, go away. What are they giving me with my survey right there? If they say, I can't talk to you. I don't want to talk to you. What are they doing right there? What kind of bias is that? When they're like, I don't got time to answer your questions. What kind of bias is that? Non-response, great job, Roger V right there. And also Davis and Jessica, excellent work. Non-response bias and Gracie and William, excellent work. So non-response bias. Now, if I like ask questions like do you think UT should? And it's like a question that people are like, might get some response bias. You never know. Pretty interesting. Oof, that's some controversial questions. That's not what I do here. Next, leaderboard. Who's in the lead right now? 13, I think. Nice. What? Oh, yes, exactly. That is the last chapter on test 2. Roger V right there. Excellent work. Helping out. Another 100 points in the chat. That is correct. Up to the sampling, and we'll do that here in a moment. The roads that the researcher samples, not a trick question. Not a trick question. The road that the researcher samples, they maybe sample 150 roads. Not a trick question. Not a trick question. Not a trick question. That's all I can say. It's like I talked to 100 students in the library. 100 students. Not a trick question. The 100 students I talk to and get data on would be my this. The roads that I take as my sample would be this. Yes, nice job. The parameter of interest is what we're looking to understand. Like if I ask students, like, how much do you think tuition should be? I might look at the average value for tuition, trying to understand the truth for what students think. And I'd get a sample mean average for like, on average, students think tuition should be this. So you could poll students and get some ideas of what they think. And that would be a sample statistic if you talk to 100 students and get some ideas. Who's in the lead? Let's find out. It is still leaderboard's locked up, but make sure to hang out and get this knowledge. Next question, here we go. The roads the researcher wants to understand. The roads the researcher wants to understand. These are the ones they care about. Like I care about UT students. So I care about UT students. I want to understand UT students. The researcher wants to understand Knoxville roads. They're like, Knoxville is a big area of interest for us. We want to take data on Knoxville roads. Those Knoxville roads would be the what? Those Knoxville roads would be the what? The Knoxville roads are going to be the population of interest. Oh my gosh. Oof. Oh no. No. So, parameter of interest. Parameter of interest is the thing we want to understand about the population, sometimes called the population parameter of interest. So the roads is what we're collecting data on. If we want to know how many potholes there are on the road or the conditions of the road, that would be the parameter. What is one parameter you could try to understand about UT students? What is one, and this is something you want to know about them. So a parameter is what you want to know about the population. So let's review this term right here. It's probably the most complicated term we have. What is one parameter you might want to know? Their GPA, like the average GPA of a UT student. Great job, Jessica, right there. So parameter would be like the mean GPA of UT students or the median GPA. You could take data to try to understand that about the population of interest. You would take a sample. Any other parameters or things you might, it's just like a characteristic. That's what a parameter is. To say like what percent of students are in-state would be a parameter of interest. I want to know what percent of students are in-state. So I want to understand UT students, and I want to understand what percent are in-state. So I'm going to go take a sample and try to better understand what percent of students at UT are in-state. I care about the population, UT students, and then the parameter of interest to me is what percent are in-state. That's a characteristic or a feature of the population I want to understand. Next question, leaderboard shakeup. Oh no, Fast Gator's back. Hey, Fast Gator, what's up? Next question, here we go. The researcher wants to understand the average amount of potholes per mile for all Knoxville roads. Fast Gator making a comeback. So this is a characteristic of the population they want to understand. This is something important to them, something they want to get data on, something they're going to collect and understand and research and maybe try and understand the truth. Like, they collect for 50 roads and then they make an estimate of the true amount of potholes per mile to see what's going on with those Knoxville roads. And so this would be what? This is actually the parameter of interest. Great job, people following along. That's what we want to see right there. Like, that's why I do questions that I think people might get wrong. And then I try to show you one where, okay, wait, this is a parameter of interest. We want to understand the population Knoxville roads, and then the characteristic of the population is the parameter of interest. We'd go out and take a sample from the roads we have access to. The roads we have access to in Knoxville would be known as the what? The roads we have access to, the ones we can get to. Like maybe there's a private road, and I mean, yeah, it's a Knoxville road, so we probably want to understand it, but we can't get to it. The roads we could possibly take from, Jessica got it right there, are the sample frame. Those are the ones we could actually go to. So a road outside of our sample frame is one we can't get to, like a private road, or maybe some road is in such bad condition, and that would be biased then, because if we can't get to it, it's a problem. Great work right there, everybody. Leaderboard time. Fast Gator still just trying to catch up, but Fearless Snail has a perfect streak. Whoa! Keep it up. You got this. Probability of making a shot is 30%. What's the complement? Nice and quick question. We should know this. This really helps for things like P and Q. Complement is a very quick trick. You just do 1 minus whatever it is. So when you hear a probability of 30% and you hear a complement, if you don't know it, put it in your calculator. It's all right. And frankly, if I'm taking a test, I'm not going to trust my math skills because, you know, calculator will help out. I'm going to think what it is and I'm going to check it on the calculator. So we do 1 minus the event. And this works for like P and Q, which are complements. And there we go. So if the probability of making a shot is 30%, the probability of not making, which is probably Brian's probability, is 70%. So P and Q and P hat and Q hat are complements. And we'll see it in later chapters. Who was the quickest on this one? Whew, leaderboard, quick leaderboard right there. Charming Lion, you got this. Here we go with the next question. The law of averages is a fallacy. The truth is what? Lots to read going on right here. Let's see. If head occurs too much, tails is more likely. Really? If you flip a coin a whole bunch of times, tails can increase in probability? I don't know about that. Two independent events can be multiplied together. Well, but that doesn't relate to this. Past events do not... Ooh. These are... That's true and that's true. And this is also true. Well, the only one that really relates to this is going to be the law of averages, which is a fallacy. That's this. The truth is past events do not influence independent trials. So that's to say, like, if you flip a coin, like if you have a fair coin, think of this. We write questions like this also. I flip a coin 10 times and it comes up tails, tails, tails. What's the probability it comes up tails next time? So there's a fair coin and I'm flipping it and I'm throwing it like super high in the air and just throwing it as high as I can. It lands tails on the ground, 0.5. And that's what we mean by past events. Like Rock knows. It doesn't matter that it came up tails a whole bunch of times previous. The coin doesn't know about that. I was actually watching a video with some old video games I played, King's Quest games, gosh. And there was a probability of a 1 in 10 chance that something would occur. And I think it occurred 3 times in a row, which is a 1 in 1,000 probability. And then I think people think, well, what's the probability it would occur again? But the truth is, since you're probably using random number generation, 1 in 10. But when you experience that, you would experience it in the sequence. And then you're like, wow, that was a 1 in 10,000 probability. But the next time you do it, it has a 1 in 10 chance of occurring again. So then you'd be like, well, that was a 1 in 100,000 probability. But that's the sequence, which you did actually experience. But once again, past events do not influence independent trials. So if that's a true random number generation, it doesn't matter. It doesn't matter that it occurred previously. The next time we do something that's a random trial right there that's independent of previous ones, it's going to have its own probability. So this is the law of fallacies down here. If heads occurs too much, tails is more likely. That is the law of averages. Fast Gator, you're doing it again. Jump up here to third, get some prizes. Here we go. Next question. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is N? This is a notation quiz. A lot of these last chapters are all about notation. And I'm even going to help you out here with the remaining questions. N stands for sample size. So this is sample size. How many students were sampled? And then we're going to do all the notation in this problem together. Be careful. Notation is a little bit tricky. Put it down on your note cards and practice the notation and practice it on the MyPearson. Pretty good, pretty good. Okay. So 200 is the sample size. What is 20? 20 is we know UT. Apparently we know UT is 20% freshmen. This is like maybe with like faculty and staff and graduate students. 20% of UT is freshmen. So what does that mean? We know that. The registrar told us. And we can trust him. We do. What is that value in notation? Let's actually take a screenshot of it and draw on it. We know UT is 20% freshmen. What is that value in notation? It is P. Daniel, great job. It's the truth. P stands for the true proportion. If you know what the true proportion is, then what else could you find? What else could you find if you know the true proportion of UT is 80% freshmen? What could you find also? So if you know 20% of UT is freshmen, you could find Q. Great job, Jessica and Leela right there. And so P hat is the sample proportion, which we actually do have a sample proportion on here in a moment. No worries, Daniel. You can find that according to this problem. You can. But we can find Q, which is the proportion of UT that is not freshmen. So great work right there. But now we see the sample size. Now this one, a lot of people get that one wrong. What is that value? In our sample of 200 students, 30 were freshmen. What is 30? This is a commonly forgotten notation. 30 is what? This is probably one of the most forgotten ones. Ow. 30 is what? Commonly forgotten notation. It's X. Meath, good job right there. That is X. X right there. And so now what do we use X for? What do we use X for? And what do we use N for? X over N equals what? Which is the number of successes over the number of trials. X over N equals what? X over N equals what? What does X over N equal? What would that equal? It's 30 over 200. Daniel? I'm hoping on Daniel for this one. It's point Rajiv, good job right there. It's 0.15, and what is that? That is P hat. And if we know P hat, we can find Q hat. So if we know P hat, which is 0.15, X over N, we can get Q hat, which is 0.85. And that's the sample proportion. Like in our sample, 15% were freshmen. In our sample, 85% were not freshmen. For all UT students, 20% are freshmen. For all UT students, 80% are not freshmen. We took a sample size of 200. In our sample size of 200, 30 were freshmen. Does anyone have any questions on the notation here? P hat and Q hat are for samples. P and Q are for populations. X is the amount of successes in a sample. N is the amount of observations that we took. Any questions on this? I hope this helps. It's a little bit confusing, I know, with P hat, Q hat, P, Q, a lot of different things going on right there. And the last two questions are really going to test your notation knowledge, because if you can write the notation for the problem, you can probably use the formulas. And that's kind of my goal, like know the notation, be able to solve the problems. Let's see, coming up right here. You ready? How's the leaderboard doing? Fast Gator hanging in there. Here we go with the next question in 3, 2, 1. Let's go. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P? P stands for the true proportion. I'm going to pause and let people try to answer. So P is the true proportion. And the true proportion means this is what is actually real. Like all the data. Remember what the registrar told us? The registrar told us. Great. Wow. 100 points again. Great job listening in. A lot of people get it wrong and put like P hat right there, but no, this is the truth. 20% UT's freshmen, so that's P. That's the truth. Great job. Next question. Leaderboard lockup. Here we go. Next question. UT is 20% juniors. From 80 students, 30 are juniors. Find the mean of the sampling distribution. Ooh. Now we're on to a tougher question, but it's not tough if you know the trick. Maybe someone knew the trick really quickly. UT is 20% juniors. Find the mean of the sampling distribution. 20% juniors means this is what? We'll do the notation here in a second. This seems like a complicated question, but when you see the answer and if you know it, you'll be like, oh, what? The answer is 7 people got it. Does anyone know the mean of the sampling distribution? If you draw the sampling distribution, what is the mean of it? So, does anyone know what the mean of it is? What is the mean of it? The sampling distribution, it's P. Great job, Meath. It is, and so what is P? There you go. Can anyone take a moment right here? We're just going to play a little music here. Find for me, great job, Rajiv right there. Can anyone find for me the standard deviation? Anyone find for me the standard deviation? I probably need to pull up the calculator. I think maybe. Sounds about right. Is it? Maybe. Let's find out. Might be. The answer is might be. I think Anthony might have it. Good guess right there, both. Let's find out. P times Q over N. Square root. There it is right there. Yep. So P times Q over N square root. And that would be the distance each standard deviation is away. A lot of the questions just ask you to solve for like mean and standard deviation and stuff like that. This is chapter 13, and it really comes down to knowing notation, knowing the notation. This is N, and that's X right there. And X over N is P hat. Good work right there, everybody. Great practice. I'm very impressed with... I always get afraid with the asynchronous course, and I'm so happy people swinging by office hours, people talking on the Discord. Really just very happy that, I don't know. Are people having a good experience in the asynchronous course? We're pausing here for a second. How are people finding the asynchronous course? I love teaching, and the asynchronous course, it's one of my hardest courses to teach because I want to pull you and definitely like it. I'm glad to hear that, Daniel. I want people to be here. I want people to like join office hours. I want people to like ask questions, and we got so many people asking questions. It's not bad. I'll take that. I love it, Christy. That's so good to hear. I'm so glad you're loving it. I'm so glad you're enjoying it. Yeah, I know, right? I like it too. Like I like it. I held off on stats a little scared, but Jessica, thank you so much. It's a good balance of in-person opportunities and do it at your own time. Leela, I'm throwing 1,000 points. Well, thank you so much, Mia. It means a lot to me. Just reach out. So if you're watching this now and you're behind, one of the biggest things I want to say is the tests are the hardest part of this class. Who feels like they're going to make an okay grade in this class because they're doing all the work? That's my suggestion to you: is do all the work. Do the Pearson, do the homework, do the quizzes, do the visualizations, do the campus content, do the insane amount of work I'm just going to stack up on top of you. Do the work. And then if the test is okay, it's okay. Yeah. So keep doing the work. We'll be done here in 2 weeks. I'm pretty good about getting grades in. Thank you to my grader. They're supposed to be working on the project. Thank you to my grader. He did a great job. Let me know. One or two, I think, have messaged me about their grade, and we changed it. If you think your grade wasn't fair, always let me know. I get the final say on grades. So huge shout outs, 1,000 points to everybody right there. Keep it up. Keep asking those questions. Keep swinging by. Roberto, I've sold his channel while introduction to statistical learning. Oh, God, it looks great. Subscribe. Keep it up. Cheers from Italy. Can we get some Italian flags in the chat right here? Can we do that? Surely. We're taking a 2-second pause right here, Roberto. We're so glad to have you here. Oh, there's no Italian flag in the chat. Well, that's a bummer. We're so glad to have you here. Thank you for swinging by, Roberto. We like that positivity. We get some people visiting from all around the world sometimes. We've got a friend over there. Where's he from? Thank you so much. Well, Roberto, we're going to see who wins coming up here. Next question on the leaderboard. Here we go. It is Fearless Snail, absolutely destroying it. Wow. Next question. Here we go. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is P hat? Now, P hat usually looks like P with a hat over it, which stands for the sample proportion. The sample proportion. The sample proportion, which means from our sample, what was the proportion of students who were freshmen? It is the formula X over N, X being the number of successes and N being the number of trials. So we need to figure out what X is. X is 30, meaning 30 students were freshmen out of our sample of 200. So the answer is X over N, which is 0.15. Great work, everybody. Good work. Don't worry if you missed it. The answer is X over N, 30 over 200. And realize that P hat stands for the sample proportion. So what is Q hat? Just quick. What is Q hat? That's going to be super important in chapter 14 when we do confidence rules for the true proportion. What is Q hat? If P hat is 0.15, what is Q hat? Boom, Leela got it right there. Super quick, 100 points. Q hat is 0.85, and great job, Gracie, right there. It's 0.85 because they're compliments. Meath showing the work, and Davis also finding the answer. So 0.85 compliments, and knowing tricks like that, that P hat and Q hat are compliments. 1 minus P hat is Q hat, and vice versa. Next question, but the leaderboard first. Here we are with Fearless Snail. Gosh, dude, you still got it, right? 2 more questions. Here we go. UT is 20% juniors. From 80 students, 30 are juniors. Find the standard deviation of the distribution. Now, I kind of helped you out earlier. Maybe people remember. We might see some quick answers. Someone might be scrolling through the chat. We did this one. I think a few people, 5 people were ready to go. This formula right here is our famous P times Q over N square root. I got to find it, Mubot. Famous quote of the day, P times Q over N square root. Where is it? Where is it? P times Q over N square root. Oh. Where'd it go? P times Q over N square root. We have so many quotes. Oh, there it is. Found it. Quote 191. It's worth it. It's worth it. It's got dancers in it. We got dancing P times Q over N square root. Check out the earlier question. I'll show it right here. There's P times Q over N square root. Thank you to the student who posted that when we were singing that a semester ago. So P is 0.20, which is the true proportion of students who are juniors. Q is 0.80, which is the complement, 0.2, 0.8. P times Q over N. N is the sample size. And then it's quantity square root. So you don't square root N. Sometimes people do P times Q over N square root. It's P times Q over N square root. So you square root the whole quantity of it. And that is the answer. So make sure when you're doing this, you do P times Q. You can see up there in the corner over N square root. I'm just going to underline it a little bit for you right here. P times Q over N square root. P times Q over N square root. And when you're doing confidence rules, it's P hat times Q hat over N square root because we don't know P. Everyone right here, I need some omres in the chat. You know that's how we roll right here. Fast gator. It could happen. I don't know. Huge jump at the end right here. We need some I'm readies, and we're inviting in Hacker Man right here. We're making it happen. It's the last question of the day. Leaderboard's kind of locked up, but you know, last question hype. Let's get ready in the chat in 5, 4, 3, 2, 1. Here we go. Last question of the day. For the sampling distribution of the sample portion, what is the third condition? The last condition right here. Condition 1 is that we randomly select our data. Condition 2 is that we take less than 10% of the population. Check out the campus contents I've been doing where I've been practicing those. I did one yesterday, I believe. And then condition 3 depends on the data. So whatever kind of data we have determines, wow. The other condition we use is large enough N when we do sample size.
Brian, what are you doing here? It's my turn to announce. You go away. Okay. Tiny Brian gonna announce the winners of the Kahoot. Here we go. Fast Gator, where you at? Oh man, where's Fast Gator? Royal Boa for $10. Great job, Royal Boa. And then Rocky Wildcat, $20 right there. And wow, 25 out of 25. Fearless Snail. I'm Tiny Brian. It's Wacky Wednesdays. And we're out.
It's Wacky Wednesdays, everyone. It's Wacky Wednesdays. Great work, everybody. Great work. Wow, great job. 25 out of 25. Who got that 25 out of 25? Who did that? Who destroyed that Kahoot? Fearless Snail, where you at? Great job. Excellent work. Any other last questions? I need to go eat some dinner. Put on a little chill music right here and end off right here. But any last questions? I want to say a huge thank you for everyone for being here. I always think it's so cool we get a visitor every once in a while from who knows where. I mean, like, I just do like, I don't know, it means a lot to me that maybe someone somewhere on the other side of the world, or like, you know, maybe just, maybe they go to ETSU or something. You're welcome, Leela. Excellent work. It means a lot to me that someone's like, hey, I used your videos to help me learn this topic. I'm like, that's cool. It's what we like to do. Yes, good job. This is a tougher exam, so not trying to scare you. You're welcome. Great work. This is not the toughest exam in the world, but it's a little harder than test one. Just there. Number one thing you can do if this exam doesn't go well, giving you your pep talk right now, if it doesn't go well, you say, you know what? I'm just going to keep doing all the work. Can't stop me from doing the work, Brian. You might be able to take me down with one of your exams. Your exams are tougher than the material. Too bad. I'm going to do all the work, and I'm going to get a great grade. So do that. Get your revenge on the assignments. Yeah, no, it's not like the toughest exam, but yes, flashcards, upload them. Thank you. A lot of people really took some amazing pictures. I mean, I'll trust you if you take a picture of like 10 and 15 of them. I'll trust you. But man, some people, like, I'm telling you, I saw some pictures of like 50 flashcards. I was like, someone like stand up on a ladder or something, like got on top of their house and like took a picture of 200 flashcards on the ground on their driveway. Not literally, someone didn't do that. I saw a lot of like on the floor, like a major, like I'll trust you if you take a good picture of 20. If you just spread them out, doesn't have to be so perfect. So don't worry about, like, I don't want you to have to spend 30 minutes taking a picture. You know, if you just like take your flashcards, just lay them out a little bit and then bring it back together, that's fine. I was just like, man, some dedication. I was like, let me go look at the flashcard pictures. Like, whoa, people really taking those pictures. Well, I'll play one more song here. Great job, Jessica, Daniel, excellent work. Well, with that, it is time for some dinner. I'll talk to everyone later. Natalie, good to see you here. Until then, when do we get the bonus for the flashcards? End of the semester. End of the semester. So the bonus is for all the tests. Make sure to keep doing the flashcards. Make sure to keep practicing if what you're doing is working, especially if test 2 you get a good grade. Keep doing what you're doing. Jessica, great work. Bye. If what you're doing is working, keep doing it. If test 2 doesn't go well, then please keep doing all the work. But then you got to figure out, okay, what didn't click right here? What didn't work? Bye, Mia. Bye, Meets. Good to see you here. And with that, it's time, everyone. Time to go. Bye for now. Bye.